It is a pleasure to be here. They only called me a couple days ago, so we had to throw this together kind of quickly, but I do present fairly regularly, so it isn't that big of a deal. But it's always, I got to say, it's always fantastic to be presenting at home. There's a lot of people here that I recognize. It's a lot friendlier than the last time I was in Paris, for instance. Now, for those of you who don't know, I'll just ask, who here knows what salt is? Oh, I'm home, and we're only at 40%. Well, we can fix that. That's why we're here. Now, so let me introduce myself very quickly. My name is Thomas Hatch. I'm the primary author of SALT, which is an automation platform, and we're located here in Utah, despite the fact that we have a rather serious international presence. Now, SALT has one of the largest open source developer communities in the world. Last year, we were the third most active merger of pull requests on all of GitHub. We have over 800 people actively developing SALT right now, and that number continues to climb at a staggering pace, which does make us one of the largest, again, open source communities in the world. SALT itself is, as I just said, an automation platform. Now, a lot of people look at SALT and they say, oh, well, SALT's like Puppet or Chef. Well, it is. Or they say, well, SALT's just this remote control thing. Well, it is. And a lot of people say that SALT is a cloud platform. And it is. Fundamentally, what we've done is created a system for ubiquitous remote control of servers at an incredibly high rate, at high speed. The benefit here is that we were able to execute live commands of an arbitrary nature on large groups of servers in a highly targeted way. What we execute on those systems is, I'll say it again, arbitrary. That means it's very, very easy for us to start hopping into a server infrastructure and managing whatever the devil we want to manage. So one of the things I'm really excited about, somebody asked the question of James, what do you do if you've got a large deployment and you want to manage many Dockers? Well, in SALT, we just introduced in the last version, which came out 3 weeks ago, we just introduced automation systems for Docker and for raw LXC. So now via SALT, you can easily have, from a central location, the ability to execute commands to get status of Docker or LXC containers across tens, hundreds, and thousands of servers so that you can get those summaries instantly of what's going on. But you can also execute to spin up fresh Docker images. You can also go out and communicate with those systems in any way that you'd like. Also, you can make it so that you can do very complex configuration management in or out of things like containers and virtual machines. So that's what we mean when we talk about an automation platform. The ability to reach out to the infrastructure and change what needs to be changed, see what needs to be seen, and have the utmost flexibility with respect to how it works. Now, wrong way. I'm obviously not very fluent with slides. Okay, so I mentioned before that SALT is fast. SALT was principally engineered to be able to send commands to large groups of systems in parallel and get information back from those systems, and information pertaining to, whatever you want. Now, SALT was originally written on top of a system called ZeroMQ. Who here has heard of ZeroMQ? Oh, see, I've lost to ZeroMQ on awareness. That was like 86%. Okay, that's all right. ZeroMQ is pretty freaking awesome. So ZeroMQ is a messaging and queuing library for sockets. Very, very powerful, very, very useful stuff. And that's principally what's allowed us to be able to do things like communicate with 10,000 servers and get messages back from all 10,000 servers in a matter of a couple of seconds. Okay? Now recently, to the transport medium, we've had a lot of different demand for taking different approaches to how our underlying communication system works. And what I'm talking about here actually ties into another aspect of SALT. SALT is a system which has been made to be extremely modular and extremely flexible. The idea there being that everybody's deployment is different. How many of you have gone from one infrastructure or one development shop to another and everything was the same? As often as many people out there, we love to go around and say, this is the philosophy of the future. But everybody disagrees. Everybody's finite points are different. The only way to solve problems on a large scale is to have a platform which is fundamentally flexible enough to solve the targeted problems of the underlying installation. Okay. And so that's why inside of SALT, we have our original transport system over ZeroMQ, very fast, very reliable. But we also last year introduced SALT SSH so that you can do all of these automation routines, push out commands, do configuration management with SALT, but you don't need to install a new agent. You can use the existing SSH agent that's out there inside of your infrastructure, which for many of our users and customers, this made a lot of sense. And then we had another camp of our users and customers who told us that we were stark raving mad, that this was the stupidest thing they'd ever heard. And we said, well, that's fine, you don't have to use it. I don't even have to install it because of the way SALT has been made to be modular. Similarly, we've got customers now who are asking for a different approach to the networking. And so I'm very excited about our next release, which is codenamed Helium. We'll be introducing our initial deployment of a system called RATE, which stands for the Reliable Asynchronous Event Transport. Initially, it's a UDP-based transport, which, at least in some of our tests thus far, we have a few more optimizations to make, is faster than ZeroMQ on the communication end, and just as, if not more, reliable. And it gives us a lot more control over what's happening inside of our network stacks, which gives us more flexibility. Okay. So that's really the foundation of SALT. It's this idea of remote execution, remote control, controlling lots of servers. Now, on top of that, we said, well, if we're going to be controlling a lot of servers, then what we need to be able to do is have a powerful way to interact with those servers. And so when SALT sends out remote commands to remote systems, it accesses a very large library of routines, of system management routines. These system management routines make it very, very easy to do something like get the network information from every server regardless of OS, platform, etc. It doesn't care if it's Linux, BSD, Windows, Mac. It's going to return all the network information in the same data structure so that it's very, very easy for you to deal with. Similarly, you can say, install a package on all of these systems, and it'll know to use yum or apt, anything of that nature. So there's a vast and very powerful library of routines at your command, but on top of that, we built a configuration management system. Now, configuration management, of course, is nothing new, especially to this crowd. But the SALT configuration management system decided to do a few things a little differently. One, it is a fundamentally declarative system. Now, the reason why I made it fundamentally declarative in nature was because if you have a declarative configuration management system, you do have more underlying power with respect to what you can do inside of your routines. But there are many, many, many benefits to having an imperative system as well. And so in a recent release last year, which we updated the config management system in SALT thus that all of the routines for your configuration management always execute in the same order. And they always execute in the order in which they're defined, which means that it allows you to create routines which can be either imperative or declarative or both. It also means that every time you do deployments inside of our configuration management system, everything is going to be deployed in a completely finite way. They will always run in the same order and always run in the same way regardless of platform. Okay? And so again, our approach to that was to say, to that particular debate, was to say, fine, we'll do both. There's no reason why we couldn't, and so we did. Now, the other nice thing is that the way in which the configuration management system in SALT is built is that it's entirely data-driven. So we have a compiler in this runtime for doing config management and rolling out changes and making sure that our states are all lined up cleanly and all that jazz. But everything's data-driven. So it's all just data structures, dictionaries or hash maps or whatever you call them, depending on your programming language of choice, of course. Dictionaries, lists, strings, integers. That's it. It's all JSON serializable. So another aspect of SALT is that all communication, all return information from SALT is JSON serializable, so that it can be naturally plugged into virtually any other interface you can dream up. Okay. But the compiler, since it's data-driven, we don't really care how we get the data. And so by default, you define your config management using YAML, but if you'd rather use a programming language, you could do that as well. We ship a DSL that runs in Python. If you'd rather use raw JSON, you can write them in raw JSON. Some people do. It doesn't make sense to me. The YAML looks much better personally. But people do. We let them do whatever they want. Okay. So again, we're talking about having many, many different management layers with respect to what we can do inside of SALT. So that's probably the least I've ever spent talking about our config management system. It's usually our main highlight. A lot of people come to SALT because they want config management in SALT, because it's faster, it's leaner, the files are smaller than anything else that's out there. Very, very easy to learn. Most people are able to translate entire infrastructures over very, very quickly. And by quickly, I mean we've had people take other config management managed infrastructures and translate them all over to SALT in a matter of weeks. One of my favorite examples of that is the entire backend for Hulu. Okay. But I want to go back to something that I lighted upon when I started talking. And this is the fact that since we've got this generic communication library that we're able to interface with, well, we can manage whatever it is that we want. And it ties right back into this question of how do you manage a large deployment of heaven knows what. Now, we've got a stick of butter here because, well, and it's salted, of course. But we've got a stick of butter here because when I originally wrote SALT, the intent for it, or the original intent for it, the config management system was written within I started writing it 2 months after I first got SALT out the door. But the original intent was for it to be the back end for a cloud controller, an interface that was able to go out, talk to hypervisors, and spin up and manage virtual machines on them. And my main idea behind this was that we could manage a cloud without having to have a database that's generally out of sync or old, and simplify the overall deployment. SALT's really easy to deploy. You stick an agent, we call them minions because, I mean, why not? But just stick an agent out there on your servers. All it needs to do is know where the master is, and you're up. Very, very easy to deploy. When LinkedIn first deployed SALT, we went back and asked them, how long did it take you to deploy SALT inside of your first production deployment? And they said it took 30 minutes, and that deployment had 6,500 servers. So it's not hard to deploy. Okay. But so, again, I wanted to make a cloud controller. So the first cloud controller I made, which is deprecated, was called Butter. And then I threw it promptly away and focused on config management. But more recently, we have put a lot more effort inside of our SALT LXC, SALT Docker, and SALT Vert routines, as well as our SALT Zen routines. So now we have many, many production deployments around the world which are using Salt to manage KVM virtual machines, Zen virtual machines, and we're just starting to get into LXC and Docker containers, which again has been very exciting. Now, this is the picture that I've really been trying to paint thus far. There's a phrase that goes around in the cloud world, which is "don't have pets, have cattle." Has anyone heard this before? Okay, I've got some yeses. Right in the middle, there's this resounding, like I'm a complete idiot. How dare I? But the idea being that when you deploy servers into an infrastructure, you don't want to have to be babysitting them and updating them all the time. When you've got a new deployment of software, you deploy a new server or you deploy a new container. And so this philosophy of we should use cattle because they're more disposable in the way in which they're managed than dogs are, because we love our dogs much more than we love our hamburger. Well, we love our hamburgers. But so that's the term that goes around in many of these cloud management systems. But inside of Salt, we've got a philosophy more of, sure, if you've got cattle, then you're still going to have a dog to take care of them. We have never, and we've seen many, many infrastructures at this point that we've been involved in deploying, and we've never seen an infrastructure where they would be able to pull off making the entire infrastructure disposable. It just doesn't make sense. And then that goes back into another philosophy, which is this question about, should we use config management for deploying our apps? Or should we use images for deploying our apps? And over time, these two ideas have kind of wrestled with each other. They've taken the limelight in different order. I mean, we go back not very far ago, not very long ago, and we see many companies that were deploying their servers based on images that were being pushed out to bare metal hardware. And then we see a big popularity around config management systems, and now we see that images are becoming more popular. And honestly, what I think is that we're just seeing the fact that infrastructures are different. Everybody does it differently, which is why our approach to infrastructure management is that we are a system which can manage containers, virtual machines, config management, monitoring, whatever it is that you need can be fundamentally managed with Salt and in ways which are faster and more efficient in most cases than anybody else that's out there. I do want to mention we've got that little etcd bullet down there. We added extensive etcd support into Salt as of yesterday. I'm very excited about it. It's quite cool. If you don't know what etcd is, don't worry about it. Now, the last thing that I want to talk about here, because I'm almost out of time. Actually, am I? Yes, I am almost out of time. Is some of the internal things that we do with Salt. This is an example that a lot of people really like, and that is how we manage our test suite. So if you go to jenkins.saltstack.com, you'll see that most of our tests are failing on develop right now, to my embarrassment. We're in the middle of a bit of a refactor on a few things. That's my excuse. But you'll see that we are testing Salt against many different platforms. Now, the way that we do that is that we've got a Jenkins server, and from said Jenkins server, it communicates down to Salt every time a commit goes into GitHub, which happens quite regularly. We were actually accused of DDoSing the Python Read the Docs site because they were rebuilding our documentation something like 50 times every 10 minutes occasionally because our development activity was too quick. But on this Rackspace system, we get a new commit in, and it goes out and communicates using Salt Cloud which I haven't talked about at all, but Salt Cloud is our system for communicating with public and private cloud APIs. So it can communicate with EC2 and Rackspace and DigitalOcean, of course. DigitalOcean's awesome, by the way. I mean, I like those guys. Our test suite is running on Rackspace. I'm really sorry. I'll explain why I'm sorry in more ways later, not on stage. But mostly because that's, what we had when we built it. But anyway, spins up these virtual machines on Rackspace using Salt Cloud, communicates with the virtual machines once they're spun up, has the virtual machine run the test suite, and then we spin it down and destroy it when we're done. So we're spinning up many, many thousands of virtual machines and destroying them continually on Rackspace on a very, very regular basis with our own software. Another thing that I want to point out is that our test suite is directly hooked into Docker. So you can say that we want to run the full Salt test suite inside of a Docker container. Now, this is useful primarily because we're a system management platform and an automation platform. To truly test what we're doing, we generally have to make changes to the underlying system. Like install packages and create users and things of that nature. Our test suite, our integration test suite can be run from the command line to make a Docker image, pull that Docker image down from Docker site and execute within it, which again, we're infinitely grateful to the things that Docker has done. All right. Now I am out of time. Thank you for your time.